Okay, so inverse functions, the way we notate an inverse is like this. We're going to have a -1 right there, a little -1 there. So this is the function, and this is its inverse. You'll also see it written like this. Regularly, you'd have y, and then if you want the inverse, it would be y with the little inverse symbol. Okay? So you might see it both ways, with a y or with an f of x. Okay, so that is the notation for an inverse. And these are going to be the steps that we do to find the inverse. Step number 1, if they give you f of x, you can always think of it as just y. Okay? Step 2, you're going to interchange x with y. Then you're going to solve for y and rewrite it in the inverse notation. So those steps probably don't make sense to you right now. So let's go ahead and do an example. All right, so here's example 1, or example 6, I guess. So this says y equals 5x. Remember, f of x is the same thing as saying y. So the very first step is, or the next step, is I interchange x and y. So I'm just going to switch their positions. X will go here, and y will go there. We switch the x value and the y. And now you just solve for y. So guys, how will I get y by itself? Yep, divide everything by 5, this side and that side. So that's my answer. So I'm going to write it as inverse is x over 5. That is the inverse. Okay, let's do the next example. So I'm going to rewrite this as y equals x minus 7. And then we interchange x and y. So now I'll put x equals y minus 7. And then I solve. So I'll just get rid of that minus 7 and add 7 on this side. So that means the inverse is x plus 7. X plus 7. All right, let's do the next one. Yes, you should see a pattern. It just undoes it. Here they're multiplying by 5. Here they're dividing by 5. Here they add 7. Here they subtracted 7. Inverses, they do the opposites of each other. Okay, so now we're going to switch. I'm going to do x equals y minus 8 divided by 3. So the last thing we did to this side was divide by 3. So the opposite would be to multiply this side by 3. So I'm going to write down what we have so far. I have 3x equals y minus 8. I'm going to cross out this minus 8 and put a plus 8 on this side. So my answer is, the inverse is 3x plus 8. All right, final example. Change this to a y. So what we're going to do is switch x and y. So this will be x equals -2/5 y plus 1. And now you do algebra to solve. So I just subtract 1. So I have x minus 1 equals -2/5 y. And how do I get rid of this? Okay, multiply it by 5. Okay, I can do that. Multiply this side by 5. So I'm going to get 5x minus 5, because I distribute, equals -2y. What do I do now? Yep, divide by -2. Everything by -2. So my answer is, the inverse is -5/2x, and this negative and negative right here will be a positive 5/2. That is how we solve it algebraically. Now, I just want to point out something cool about inverses that you will notice. I'm going to pause here. Okay, so we just graphed our original one, y equals x minus 8/3. And what did we say the inverse of that one was?
Y, the inverse on y is 3x plus 8.
3x plus 8. Uh-oh, I'm not typing. Y equals 3x plus 8. Perfect. Okay, so that's my inverse. So guys, what I want you to notice here is the inverse is always reflected across this line. This is the line y equals x. So notice this part mirrors this part, and this part mirrors this part. It's a reflection across this diagonal line, y equals x. Okay, so inverses will always look like that. All right, so let's go back to our notes. Okay, so now we're going to do the inverse. These aren't linear equations anymore. Now I have a quadratic. Okay, so the process is still the same. I'm going to think of this as a y, and you switch them. So I'm going to switch x and switch y. Everything else in the equation stays the same. And we're going to do algebra to get y by itself. So I'm going to add 9 to both sides. So I get x plus 9 equals y squared. And what's the inverse of a squared? Square root. So square root both sides. The square root will cancel out with the squared. So I'll get the inverse is x square root of x plus 9. So let's talk about this part. This part is interesting. I'm going to graph it again for you. All right, so notice on this problem, this is what I have. I'm graphing it. Up here, though, it said only for x greater than or equal to 0 is what's written on your paper. So we graph this line. It's the red one. However, guys, they only want the red graph for 0 to infinity. It only wants the x values that are bigger than 0. These x values are not bigger than 0, so we don't count that part. Okay? So let me highlight what we're looking at. We're looking at the line from, let me scroll up. Let's scroll up a little bit. Okay. We only want the line, let me highlight it, from 0 to infinity. We only want the x values that are bigger than 0. So I'm only looking at this part of the graph. And look at the inverse. This was the inverse. So you guys see how it's a reflection across the diagonal? They mirror each other. Okay? So the reason why we didn't include this part right here is because if we were to reflect it, it would look like this, and that's not a function. It doesn't pass the vertical line test. That's why they restricted the x values. Okay? All right, let's go back to our notes, and we'll do the next one. Number 11. So I can think of this as y. So I'm going to have x equals, we switch the location of x and y, and then we solve for y. So first, the last thing we did over here was subtract a 6. So now I'm going to add 6. So I have x plus 6 equals y plus 4 cubed. Now, to get rid of the cubed, you're going to do a cubed root. Cubed root. Okay, so the cubed root will cancel out with the cubed. So I have the cubed root of x plus 6 equals y plus 4. We're nearly there. I'm going to get rid of this 4 and subtract 4 on this side. So that means my answer, the inverse is the cubed root of x plus 6 minus 4.
I thought you subtracted.
All right. And would you guys like to see the graph of this? I'll just draw it so I don't have to go all the way to Desmos. Okay, so this one, it looks something like this. And then the inverse looks like, I'm not good at drawing. It looks like this, so that it's a reflection across the the line y equals x. Okay, so if I put it in Desmos, that's what it would look like. All right, so let's go ahead and move on. So guys, inverses, you can find the equation algebraically by switching x and y, and you can also graph it. And when you graph it, it'll reflect across this diagonal line, y equals x. Okay, all right, let's go ahead and move on. Okay, so let's verify whether two equations are inverses or not. What if I give you two equations and I ask, are these inverses? This is how you can tell. Two functions f and g are inverse functions if and only if this f of g, so this is what we learned the other day, and g of f equal x. So they both have to equal x. The compositions of both functions, they have to equal x. And we'll see an example of that. All right, so let's do an example. You do the composition of f of g and g of f, and they both have to give you x. So let's look and see an example. So let's look at number 12. I'm going to first do f of g, and I'm going to see if that gives me x, and then I'm going to do g of f, and I'm going to see if that gives me x. All right, so let's do this. I'm going to put g into f. I'm going to put g into f. I'm going to write f nice and big, and then I'm going to put g inside of there. So I'm going to erase this, and I'm going to put this in there. So I have the square root of x minus 8. So let's see. Guys, look what's going to happen. The square root cancels out with the squared. So I'm left with x minus 8 plus 8. And then minus 8, negative 8 plus 8 is just 0, so I'm just left with x. Now, we have to make sure we get x when we do it for this one. So let's go ahead and do the next one. I'm going to put f inside of g this time. So I'm going to write g nice and big, x minus 8. I'm going to erase this x, and I'm going to put f inside. So this is f. I'm going to put that inside of here, x squared plus 8. Okay, so let's see what happens. Notice, guys, 8 minus 8, that's 0. That's gone. Oh, and the square root cancels out with the squared. So what am I just left with? So guys, are these inverses? Yes, they are. If I were to graph this, it would look something like this. And if I were to graph this one, it would look something like this. They reflect across the x-axis, or the line y equals x. Okay? The reason why I didn't continue this one is because it just wants x bigger than or equal to 0. They just want this half of the graph. Okay, but that's what those two graphs would look like if I graphed it. All right, let's look at the second problem. Okay, next problem. Okay, so now I'm going to do f of g. I'm going to put g inside of f. So let's see what I get. I'm going to write f nice and big. It's minus or negative 4x plus 5. And I'm going to put g inside of there. So g is right here. I'm going to put that in here. X over 4 minus 5. Okay, so guys, whenever I have a parentheses, what do? Multiply it. I'm going to distribute it in. So negative 4x over 4, that's just negative x. Those 4's cancel. Negative 4 times negative 5 is 20. Plus 5. This simplifies to negative x plus 25. Oh, did that just leave me with x? No, so I already know these are not inverses of each other. I don't have to do the next one. I'm supposed to end up with x and x. Everything should be canceling out. if they were inverses. Okay? All right. Let's move on to the next part. We're almost done with the notes, guys. Yep, we're going to graph. So guys. All right, so we're given the triangle ABC, and it is formed by the points in the relation -1, 6, -7, 2, and -5, -3. Guys, go ahead and graph that, and we'll come back. Graph it on your paper. All right, guys, you should have drawn that triangle. Connect those points. So I want to know, what is the inverse of this relation? Guys, whenever you do inverses, X and Y just switches. X and Y just switches. Okay, so what I'm going to do is, my inverse will have these points: 6, -1, 2, -7, and -3, -5. So now I'm going to graph those points on the same graph. All right. So those are inverses of each other, those two triangles. Notice it is reflecting across the diagonal line, y equals x. Inverses are always reflections of each other across that diagonal line. Okay, so that's what you should notice. I'm going to call this triangle ABC, and I'm going to call this new one triangle ABC. They are reflected across the x-axis, or not, sorry, reflected across the line y equals x. Just like all inverses are, they are reflected across y equals x. All right, so this one, guys, you know how to do. I'm just going to graph this line real quick. I'm going to go up to 8. My slope is 2, so this is my line. Each point should be going up 2 over 1, up 2 over 1. So this is my line. Okay, and now we want to find the inverse of it. So you can do it algebraically like we've been doing. You know, you switch x and y and solve, and then whatever line you get, you can graph it here. Another way you could do this is I can make a table. So the points that I have on my line, this point right here is -4, 0. This point right here is -3, 2. This point right here is -2, 4. This point is -1, 6. And this point here is 0, 8. What do you think you're going to do to get the inverse? Switch them. So this will become 0, 2, 4, 6, 8. This will become -4, -3, -2, -1, 0. So you can do it algebraically, or you can do it with like this. So 0, -4 is here. 2, -3. 4, -2. 6, -1. 8, 0. So guys, it looks like this is my inverse, and I'll just continue the pattern. Quiet, please. All right, so guys, notice it is a reflection across the diagonal line. All those points mirror each other. So guys, you may go ahead and do the next one. I'm going to leave that one for you. I'm going to do this one right here, number 16. Okay, so if you don't know how to graph this line, I'm going to have you make a table. So everyone go ahead and make a table for this. I'm going to do X and Y. So guys, I'm going to plug in 0, 1, 2, 3, and 4. And now you just plug it into your equation. So I'll do the work over here. What is 0 squared minus 4? Yep, negative 4. What is 1 squared minus 4? Yes, negative 3. What is 2 squared minus 4? 0. 3 squared minus 4? 5. And I'm going to do just one more. 4 squared minus 4? 12. Okay, so graph those points. So 0, negative 4 is here. 1, negative 3 is here. 2, 0 is here. 3, 5. Guys, stop talking, please. 3, 5 is here. And 4, 12 is up there somewhere. So it looks like it goes like that. All right, now I'm going to do the inverse graph. Remember, the inverse symbol has a little -1 here. So make sure you put a -1 in the table. And we just switch the X's and Y's. Okay, so I'm going to graph those. -4, 0. -3, 1. 5, 3. Oh, 0, 2. There you go. Notice that these reflect across the diagonal line, y equals x, just like all inverses do. So that is the inverse. Okay, so really quickly, guys, I want to talk about the original line. This is the original line, y equals x squared minus 4. Can you guys tell me what the domain is for the original one? What are the x values? Yep, they're all greater than or equal to 0. What about the range? Here's the bottom. Where is it at? Everything's bigger than -4, right? Everything just goes up from here. There's nothing down here. Okay, so that's the domain and range for the original. Let's talk about the domain and range for the inverse. So I'm going to do it in red since this graph right here is in red. So the inverse, can you guys tell me what is the domain of the inverse? It's right here on the left. Where's that? -4. So all the x values are bigger than -4 or less than -4? Bigger. Okay, now let's do the range. All the y values are, here's the bottom, greater than or equal to 0. Perfect. What do you notice about the domain and range of the inverse? They just flipped. So just like when you do inverses, x and y switch, the tables, x and y switch, the domain and range just switch. So notice, the domain for the original is now the range of the inverse. The range of the original is the domain of its inverse. You guys see that? Okay. All right, so I'm going to stop here. That was the end of the lesson. Now we're going to practice.